This is the wind of change. It's a wind tower made almost entirely out of wood. It's also one of the tallest wooden structures in the world. People were telling me 105 metres, is that right?
Yeah, it's right. It's really, that's the hub height. The total height is 150 meters, so to the tip of the blades.
But you know, as I thought 105 metres, oh that's tall, but still I can't get it into my head.
No, it's
until you stand here.
Yeah, it's quite big.
It's very, very big. I understand we're going to go up inside this tower.
Yeah.
I've got one small problem. I'm terrified of heights.
Oh, you have a challenge.
I do have a challenge.
No. We will keep you safe.
Yeah?
Yeah. Maybe not okay, but safe, but maybe not
definitely
totally okay.
Definitely not okay. But, all right, well, I believe we have
we'll
to
take care of you.
Yeah, you may have to carry me. Wind towers are being built all over the planet as part of the transition to green energy. But is all that infrastructure clean and green itself? The average onshore wind turbine has a capacity of around 4 megawatts. A tower that big needs around 480 metric tonnes of steel. But producing just 1 tonne of steel can release up to 2 tonnes of carbon dioxide. And making a tonne of cement, the main ingredient in concrete which is used in the tower's base, can produce an equal amount of CO2. David and his team of engineers think they can reduce all that by using wood, one of nature's oldest materials. So David, how does a boat builder from Gothenburg build one of these?
If you do traditional boat building, you get interested in wood and the strength of wood. I also wanted to really explore what is the ultimate construction from wood. And a wind power turbine is really one of the most dynamic loaded systems you can have, because it has to stand for a lot of years, like 35 years.
And that's in the nature of wood, isn't it?
Yeah, they're made for that. They're made for carrying a small power plant, but it's a solar power plant, right? But that solar power plant is exposed to wind. So the pole that carries it has to be really optimized for taking wind loads.
So why choose wood over traditional materials like steel or concrete, or composites of both?
It's carbon dioxide, of course. That's one of the main reasons, of course. And then it's also very strong by weight. So it's stronger by weight than steel. So that makes the transportation easier, because the large pieces you have to transport, they're lighter, so you can transport more of them on the same transport.
The advantage then, I guess, is that you can get them anywhere you want.
Yeah, you have to get them anywhere, because we are building wind power plants in all over the world right now. And it's really going to have a system that is possible to transport on regular roads.
Can you see these therefore reaching, because of their lightness, reaching areas that haven't been accessible up till now?
Yeah, because in the low wind areas, for example, in the middle of Europe, when you're building a lot of wind power right now, you have quite strict traffic regulations, really. So that's bridges, heights and all that. So this is really opening up.
What about in wilderness and, out in the far wild areas?
Yeah, same. It's the same.
Could you transport the modules by helicopter? It just occurred to me.
You could, but you need a very big helicopter. You know, the modules are from 7 to 15 tons.
All around the world, countries are investing big in wind. Europe is estimated to boost its wind power capacity by around 390 gigawatts by 2030. That's enough to power an average of 212 million more homes for a year. But that's still short of the EU's target of 425 gigawatts. So Europe and the world need to build more.
So, welcome.
Oh, thank you very much.
Woo-hoo!
I see a very safe looking lift there. Back to my fear of height. Why do I need that? Why do I need this harness?
Because if we need to evacuate, for example, or if we need to take you down,
Yeah.
because you had a kind
Heart
of
attack.
panic attack or something,
Yeah, panic attack.
We need something to carry on.
So, okay. I'm not at all anxious about going up really high on the inside of a windmill. No.
It's all going to be fine. You'll be fine. You'll be. And if anything happens, we will save you.
You will save me.
Yeah.
I have your promise. It's on camera, you saying that.
Yeah.
So I've got a record of that. My wife will hold you to that.
Yeah. She can. Have it more tight.
Thank you. Me first.
Yeah.
Very, very cozy.
It's very cozy indeed.
David and I might have to get married after this, Joe.
You ready?
Yeah. Good news is I can't see much.
No, but now you can start seeing the wood.
Right. All the beautiful wood.
Yeah.
It turns out I didn't really need to worry about the height after all. Safety regulations meant we were only allowed to go part of the way up the tower, to the second level. It's like being in a wooden cathedral.
Yeah. It's like a very tall, not very wide concert hall.
Concert hall, that's better than cathedral.
Yeah.
Because it sounds like I want to sing, sadly I can't.
We've been singing a lot in this tower when building it. Yeah. And it's totally untreated here.
Oh, that's a good point.
Yeah, because we control the climate inside.
Yes.
So climate is very stable. So nothing really happens with the wood. So we don't need to treat it. But on the outside, it's of course covered and painted white. And it's a very thick and very sturdy coating.
So this is pretty big. This is 105 metres tall. How big are you aiming for?
It's going to be 166 meters.
Right, 2/3 taller than we are already.
Yeah.
So this will be huge in here.
This will be huge. This will be like 9 meters.
It'll be really like a cathedral.
Yeah, it'll be really huge.
It seems that you're in pursuit of ever taller. How tall is optimal?
Well, it's very difficult to say. Maybe tower heights of 200 meters up to maybe 250 meters.
Explain to me though, why actually is higher better?
It's better because you have more stable winds.
Right.
And you have more winds, you have stronger winds, and you can have larger diameters.
And the bigger the propeller, the rotors, the more air you're catching, I guess. Is that
Yes.
the idea? Right.
You can harvest much more wind energies. And the fewer power plants you need. That's also something. When you do the repowering in the old wind parks, you go from maybe 15 turbines to 2 or 3. That's also a difference.
Modvion says that constructing wind towers with wood rather than steel can reduce their life cycle emissions by at least 25%. And because wood is also much lighter than steel, it makes it easier to build those taller towers that David was talking about. All of that could give wood a competitive edge, and it comes down to how the material is manipulated. Otto Lundman is Modvion's co-founder and CEO.
So this is Modvion's first factory, and we get these huge plies of LVL into our factory to make our things.
So that's what I'm looking at here.
Yes,
LVL.
laminated veneer lumber. So thin slices of wood made into boards, like huge plywood.
That was going to be my next question. How is this different to plywood?
In plywood, you usually have every set of veneers, every layer of veneers, 90 degrees from the one adjacent to it.
Right.
In LVL, you can steer the direction of the fibers, and that's important.
Steer,
yeah, so you can have all fibers in the same direction,
Yes.
or one here and there in a different direction, and that's what we do.
Can we tell which ones are going in which way here?
Yeah. So you see here, these 9 top veneers here,
Yes.
that's one board.
Yes.
And you see here in the middle,
Yep.
there's a cross.
So there's only one of them coming this way.
True.
Right.
And hence we have a lot of strength in this direction, because the fiber direction will be the stronger direction in the boards.
Yeah.
So this bit in the middle that's coming this way, it presumably gives you added strength for when you turn it.
Yes, for that.
Yeah.
And also, when we have completed these into a tower for a turbine, there's also going to be torsional loads in the tower itself. So we need for both.
So, you know, I know, I play around with wood a bit, but, you know, for most people, they'll find it very difficult to believe that you can build structures the size of what you're building out of wood.
Yeah, because of what we've been using for large-scale construction for the last 100 years.
Right.
But there's a lot of advantages to this.
Yeah.
Engineered wood products such as this, they have a lot of strength per weight and a lot of strength per cost.
Right.
And as you go taller, larger structures, the eigenweight of the structure is also
eigenweight? What's that mean?
the weight of the tower itself. You need and the turbine on top of it. You need to combat that.
Eigenweight basically measures how the tower's total weight can affect stability. Remember, a wind turbine tower is under constant pressure from wind, blade rotations and gravity. Analysing the eigenweight helps engineers build sturdy towers that don't shake too much or break when the wind blows.
If you do that in a heavy material, such as concrete or steel, then you need to make a stronger tower just to handle the weight of the tower itself. But using wood, we get the same strength with 30% less weight. So it's an advantageous material.
And that's because of the fibres of the wood?
Yes. So it's a fibrous material. We call it nature's carbon fiber.
Right, okay. Well, that's exactly what it is.
Exactly.
But it strikes me as a bit of a scientific irony that by manipulating wood like this, these engineers are giving it a role it's already been playing for millennia. However, trees are fragile beings, taken down by the very forces of nature they're built to withstand, as well as their own flaws. Otto, I'm still obsessed by, is this strong enough, right? I look at this, you know, the knots, you know, and the little imperfections. How does that affect the strength?
Well, this is a biological material. You're going to have small weaknesses like this.
Yes.
But then look at this.
Yeah.
So it's a veneer material.
Right.
So even though there is a knot here, it's not a knot in the next 8 veneers.
Right.
Or when it's put into a tower, it's not going to be weaknesses in the next hundreds of veneers.
Right.
So you can actually calculate with the full strength of the material.
So there might be a weakness there, but there isn't there or there or there. So it cancels out. Right.
The wall thickness is a lot more than one board. It's 20 to 40 millimeters.
But now I'm thinking about the round tower, right? So if I try to bend that, I'm not having much luck. So how are you bending this into a tower?
We don't bend that because this has the veneers and the fibers in that direction.
Right.
So we take, this is from the same board.
Yes.
But this has the veneers in that direction. And quite flexible.
So same material, but because of the cut, completely different properties.
So by controlling the directions of the fibers. And this is?
It's a performance product.
It's a performance product.
Once the LVL boards are produced, Modvion starts to shape them into the modular parts.
So this is the lamination machine.
Yeah.
These bulkheads, they make up the mold. The sheets of LVL come in and adhesives are spread out on top of each layer. And then all of them at once are pulled down towards the mold.
So they all come in and they all get glued and then you bend them, not one at a time?
Not one at a time, that would take a long time. And the thickness depends on the design.
Right.
So the taller we go and the longer life length that is wanted,
the more wood.
Yeah.
Now that you've shown me, of course, it all seems pretty simple.
Yes, it is very simple, as good ideas are when you look at them in hindsight.
Once they're glued and bent into shape, the curved parts are cut into segments that, remember, are much lighter and easier to transport than steel. After they're driven to the construction site, Modvion starts putting the tower together.
The tower is modular, right?
Yeah.
So We make modules that are put together into sections,
Yes.
Cylindrical sections,
Yeah.
and then these cylinders are stacked
Right.
on top of one another. So in the top of the sections you have these slits where steel plates goes in, which are then covered, or the rest of the slits is filled with adhesives which holds this steel plate.
Steel plates. Okay,
Yeah.
so there is some metal in there.
A little bit of
Yeah.
it. The forces come in the wood and then it goes over into the adhesives, and over the joint you'd like steel,
Right.
strong per volume
Yes.
material to carry the strength over the joint,
Yeah.
and then it goes out into the adhesive and the wood again.
But how do you get the glue in there?
We hoist a glue machine through
Yeah.
the tower. The glue pump is just connected to these, and then the glue fills up and it comes out here in the top, and then you
I
know you're
see.
done. We need modularity, and this is much simpler to do in wood than in steel.
Right.
Modular steel towers, you get 50,000 bolts that needs retensioning
Right,
throughout
right.
the tower. We just glue our modules together.
And it becomes another bigger tree.
Exactly. I think that's just beautiful how the log pretty much roll it out like toilet paper, and then you roll it back together again, but into a much larger shape with a hole in the middle, and you have a new, much larger tree.
With all the strength of the original tree.
Yes, and this is a material that's been developed over centuries by evolution to do this.
A material that survived and shaped humanity's existence for thousands of years. But wood is also now at the heart of the climate crisis, which brings us to what might appear as a contradiction in this entire process. It's kind of counterintuitive. We all think, oh, we've got to keep trees in the ground to fight climate change, but you're chopping down trees to make these. What's the answer to that?
Yeah, you're cutting down trees, but when you cut down trees, you also grow new trees. So when a tree goes really old, it stops growing. So you can take the trees out and you can have more trees.
So it's sustainably harvested wood.
Yes.
Modvion uses softwood to build its wind towers. It's cheaper and lighter than hardwood, and there's a lot of it available in Northern Europe's sustainably harvested coniferous forests. At any given time, some parts of the forest with mature trees are ready for harvest, while other parts are regenerating and growing. This way the forest is never completely cleared and keeps absorbing carbon while ensuring a steady supply of wood. What's the lifetime of this tower? How long is it built to last?
Every single wind power tower is built to last as long as the technical components of the turbine last. So nowadays you design them for 35 years, but the tower itself, the wood itself, can stand for much longer than that, because it is in a very protected environment here. So in the afterlife, after decommissioning, we will cut it up, or not us, some companies will cut it up, make it into beams, columns used for timber building. And then it will keep the carbon for hundreds of years more. And after that, you will do something else of it, maybe boards, and in the end, paper.
Oh, okay. So it's got afterlife after afterlife.
Many afterlives, so this one, yeah.
That means the carbon could stay locked away for several decades. In fact, Modvion says their process is overall carbon negative, which means it ends up taking more CO2 out of the atmosphere than it emits. But to make a real difference, the company also has to break into a really crowded industry, one that's been around for decades.
The market we're really focusing on and where we're going is the 6+ megawatt turbine market, which is the big market in Northern Europe, etc. And which is really great for us is for that market and for most places going forward, traditional steel towers, the tubular steel towers, they don't work anymore because of logistical challenges, etc. So all of a sudden you're getting into a territory of alternative towers already, and our towers are very competitive in comparison to them.
Where does the money come from to get something like this off the ground?
Partly it's soft funding, so governmental grants, etc., supporting from the EU and from the Swedish government, etc. But mostly it's private funding. But also strategics, such as wind turbine or wind power companies or wood companies that sees the need for what we're doing and the benefit of it, and not just the sustainability benefit, but the commercial benefits of it. The fact that we can build taller, which means you have more energy production out of each turbine that you put up. And then even more so, the thing when you can actually build turbines in new places profitably, that makes it really interesting.
Are you only aiming for the European market, or are your ambitions wider?
We do have people already now reaching out to us quite often from all over the world. In the US, for instance, there's a huge demand for being able to build taller for wind turbines because of their logistical challenges. Typically, no wind turbine towers are taller than 100 meters there, while here you see 150. So they have this huge potential of getting more energy out of their wind farms. And we also have people reaching out a lot from Canada, for instance, from Australia. So our aim is to take 10% of the wind turbine market. At its current size, it's about 20,000 a year. And to be able to reach the global climate targets, it would need to 5-double really. So we will be busy reaching those kind of numbers.
Personally, I think wind turbines are beautiful, but where I live in the UK, there are a lot of people who literally say, not in my backyard. What's your answer to people like that?
I absolutely recognize that, and I really think it's something we need to respect. But I think it's also a twofold thing for me, because I like them myself. I think it's a beautiful thing, and I would rather have that than having the big climate impact and the problems that comes with that. So I think it's both in terms of balancing different interests on the global scale and on the local. But also what I think is really beautiful with our technology, because it enables you to cost efficiently build taller turbines and get more energy out, which means that you can actually build in places where you could not profitably build wind power otherwise, which means you have higher likelihood of finding places that is not in someone's backyard, that is not military area or whatever problematic, which means opening up new possibilities for that. So you don't, not as much at least, would have to run into these conflicts of interest.
That kind of conflict can actually delay the green energy transition even further. A study in the UK found that local opposition can raise wind energy deployment costs by up to 29%. But companies like Modvion believe that if we can increase our green energy capability by building more efficiently, using one of nature's oldest resources, that might make it easier to balance local concerns with the large-scale efforts we need to fight the climate crisis. Do you think the age of wood is coming back?
I think it's coming back, and it's going to be combined with these, because steel and concrete, they are fantastic materials, really fantastic materials, but you have to use them where you really need them, and that's what we are going to have to do in the future. We're going to optimize how we use materials, different materials, for what, where and when.
Climate change is happening. Humanity needs to get off fossil fuels. Electrification is key. We need more renewable energy. Wind power becomes more efficient the taller, the larger you make the turbines. So we need a better way to build huge towers. And we can make it in a renewable material and really accelerate this shift. And that's what it's all about, right?
So you had this presumably safe, regular job at a big company. What makes you come to a startup?
I love the feeling of getting to work every morning and feeling I can make a difference, that I actually work on the solutions to the world's biggest problems rather than being part of the problems themselves. So I think that's really what's needed and gives me a lot of value and a good feeling that what I leave behind, what I spend my hours on, is something that will make the world a little bit better for my children and hopefully for their children in the end.